Okay, so it's a continuation. We differentiate. Here we agree that we should differentiate. You find f of that. That will be 3 over 3x squared plus 2 over 2x minus 6. That is x squared plus x minus 6. And then you equate this to 0. You're looking for critical points. So we used positive 3x minus 2. Factorize this, and it gave us x plus 3 minus 2x plus 3 is 0. So x minus 2, x plus 3 is 0. This means that x is 2 and x is negative 3. Now from there, you pick them. You use these critical points, negative 3 and 2. So you're forming a table like they all used to form tables on when you're looking at inequalities and the like. Pick a number in between. Suppose you pick 0. Pick a number after 2. You can pick 3. Before negative 3, you can pick negative 4. And then bring the derivative. So you bring the derivative. You can bring the derivative in any way. If you want, you can bring the f prime itself, or you can bring the factorized form of this. Okay? If you want, you can use x minus 2. You use x plus 3. And then you use its product here. Because it will be the same thing. Okay? To make it easy now, after I've formed the table, then I'm saying what I'm using here is f prime of x. Okay? So I want to test its signs in this. So my table is not complicated. So when you, what is f prime of negative 4? So you're substituting in the derivative, so it will be negative 4 squared plus negative 4 minus 6. This will be 16 minus 10, which is 6. You're interested in the sign. And then what is f prime of 0? That will be 0 plus 0 minus 6. So it is negative. What is f prime of 3? So you have 3 squared plus 3 minus 6. So you have 9 plus 3 minus 6. That is positive. So what are we saying about the function decreasing or increasing? So this table tells us where the function is increasing, decreasing, and increasing. Okay, remember that initially we are saying when looking at polynomials, we said if it has power 3, there will be 2 turning points, meaning that you could sketch your graph like that, meaning it's increasing here, it's increasing, then it starts decreasing, 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 then increase, increase like that. That's what we mean by decreasing and increasing. Now you want to know where. So what we are saying now is in the interval, so in this interval, it is increasing. In that interval, it is increasing. In the middle interval, it is decreasing. Okay, so you say increasing of x is increasing from negative infinity to negative 3 and 2 to infinity. It is increasing from negative 3 up to 2. So we have these intervals using the table. Now you want to sketch this function. For you to sketch it, you must know, okay? You must know the turning points. But how do you know the turning points? How do you get the turning points? So to get the turning points, you substitute. The very critical points, so you take f of 2. Not f prime, but f of 2 now. You get this critical value and take it in the original function. So you have 1 over 3, 2 to the power 3, plus 1 over 2, 2 squared, minus 6, 2, plus 8. This will be 8 over 3, plus 4 over 2 is just 2, minus 12, plus 8. Now 2 plus 8 is, that's 10. Plus 12, we get negative 2. So we have this minus 2, which is 3 down, 8 minus 6. So this gives us what? This gives us 2 over 3. So we have this value here. This value is the turning point. Then you also find f of negative 3. That will be 1 over 3, negative 3 to the power 3, plus 1 over 2, negative 3 squared, minus 6, negative 3, plus 8. So you get 9 plus 9 over 2 plus 18 plus 8. So, well, the first one is negative 9. So negative 9 plus 18, you get 9. 9 plus 8, you get 17. So we have 17 plus 9 over 2. Then you have 2 down. Then that is 34 plus 9. If we add there 34 plus 6, we get 40. 40 plus 3, we get 43. So just adding 34 plus 9, that's 43. And then you get 2. This is another turning value. Okay, now remember, to get the first one, what did we use? We used 2. So we call this point 2, 2 over 3. And the other point, negative 3, 43 over 2. Now, since the function is increasing in here, it is increasing, then it wants to turn at negative 3. Then this is the maximum. This is the maximal turning point. And it wants to, so it will come down, decreases, and then increase at 2. So it becomes the minimal turning point. So now you're able to sketch the function. Okay. So when you say sketch the function, it was not mentioned that you must find all the intercepts. So you just sketch and take care of the intercepts. I mean, of the turning points. So the sketch will be here. At least you can find the y-intercept. Is the easiest one to find. F of 0. So it's 8. So what's important here? First, you have negative 3, 43 over 2. That is 20. That's 21.5. So we have negative 3 and 43/2. That's the turning point, and then it's crossing at 8. Okay, it has another turning point, 2,2/3. That's 2, 2/3. That's positive. 2/3. So somewhere here. Okay, so the 8 can be written somewhere else. So it will go like that. Okay, it's fine. It will go like this. So I only have one x-intercept. This one here. So it might even be easy to find. You get that to 0, the original function. That's not an easy thing. Yeah, it's not easy to find. And that's a sketch. So the question of how do we know the turning points for the, how do you know turning points for the polynomial? This is how we know. Because now we know the turning points.
Sir,
Hello?
what's the point after -3? Why you put your marker? No, on the graph.
No, we don't know
Yes,
that one.
that point. After -3.
I don't know it. So where it's possible to know it, you can. Where it's not possible, you leave it unmentioned. So gift minimal and maximal, you get the critical points and substitute in the original function. Meaning, after you differentiate, you get to 0. The values of x that you get, you substitute in the original function. They give you the maximum or minimum. How you know it's maximal? It's by looking at where it is increasing. So if it was increasing, then you find that point. Then you know that it starts decreasing. So that point is maximum. If it was decreasing, then it starts increasing after that point. Then that point is minimal. Alternatively, you can differentiate the first derivative. So the first derivative was what? X squared plus x minus 6. So you can differentiate it again. You get 2x plus 1. Substitute those values. So what is f prime prime of 2? You get 2 plus 1, which is 5. This is greater than 0. What is f prime prime of -3? You get 2 -3 plus 1. This is -6 plus 1, which is -5, less than 0. So if it is greater than 0, then it is minimal, and the opposite maximum. So that is an alternative. That is if you have forgotten. Maybe you don't know how to say it is increasing or decreasing. At least you can know the turning points, the nature of the turning points. And that's how we know. There's nothing strange. There's nothing scary. And you don't have to be scared of the exam. The exam is If there's one that is very easy, it's the 1100 exam. Especially that we have spent much time on it. It will be very, very easy. Because you find most of these questions, they'll be there. The same language. What will be changing are just the numbers. But same, they ask you, they give you a function, they ask you to determine where it is increasing and decreasing, and you know how to differentiate. So you just differentiate it, it becomes a quadratic equate to 0. You differentiate it, then it becomes a polynomial equate to 0, get the zeros, those points that you get, take them in the original function. You keep your maximum values. Those points that you get, form a table like we do on inequalities. Where I have plus, it's increasing. Where I have negative, it's decreasing. Where I have plus, it's increasing. I mentioned that. Submit and wait to go into second and do other things. That's how easy life is. Let's go to the second part. Look, I'm just looking for the question. I don't know where it is. Okay. Question 6, C2. Okay. An open cylindrical tank. Excuse. An open cylindrical tank with circular base is to be constructed of sheet metal so as to contain a volume pi a to the power 3. Pi a to the power 3. What is this? This will be the volume. Okay. Find the height and radius of the base in terms of A so that the quantity of sheet metal required may be minimal. Curved surface area of a cylinder is, you've been given now the curved surface area of the cylinder is equal to 2 pi RH. So I read the question. An open cylindrical tank with circular base is to be constructed of sheet metal so as to contain a volume pi a to the power 3 of water. Find the height and radius of the base in terms of A so that the quantity sheet metal required may be minimal. Curved surface area is given. So what do you do? When you hear about minimal, what comes in your mind? If you're just from solving A, first thing is you need to know the surface area of that kind of a cylinder where it is closed down, it's open up. So it's going to be, first you get for the open cylinder, which is 2 pi. It's even given there, 2 pi RH. This one here. And then you add the closed radius. The closed area, which is down the base. Okay. Since it's open up and open cylindrical. So it's open up, closed down. So that's the surface area. Now you are told we want where it is minimal. So it has to do with the derivative, because for us to know minimal, we differentiate and then get the critical point and substitute there, then you're about to know it is minimal. Or we differentiate and differentiate again, substitute the critical points in there, then we know it is minimal or maximum. So it means that we need to differentiate. We are differentiating the surface area with respect to the radius. So what are we getting? You get 2 pi h plus 2 pi r. From there, you get the critical points. So you get your derivative to 0, which implies that 2 pi h plus 2 pi r is equal to 0. And then you solve for, what do you solve for? Remember, you're looking for the height and the radius. So in this case, you divide by 2 pi. Okay, so you divide by 2 pi, and then you get h plus r is equal to 0, implying that r is equal to negative h. But that thing does not happen. Remember, these guys are, you cannot have the height which is negative. So you get the modulus. So r is equal to h. Okay. Now, if r is equal to h, then you are given the volume, remember? The volume there. And how do you get the volume of the cylinder? Closed. How do you? You guys, what's the formula of the volume of a cylinder, which is open up and closed?
Pi r squared height.
Huh?
Pi r squared height.
So the volume is going to be pi r squared height. But what is so where you have r, it's the same as you have h, or where you have h, the same as you have r. So you're saying this volume then is the same as pi r squared r, which is the same as pi r3. Is it? But you are given the volume there. We are told the volume of this is pi a3. So we are getting it to pi r3. So divide by pi, we remain with a3 is equal to r3. Get the cube root. Well, since the powers are the same, even the bases must be the same. So I have a is equal to r, but r is equal to h. This means that r is equal to a, h is equal to a. We are told in terms of a and h. So that's how you get the r and the a. So how does the weight minimum come into play? It's the one that allowed us to differentiate. Okay, that's the end of this question. So when you go in the exam, you don't have to go blank as in you have completely forgotten about your mensuration. And this does not mean you should start revising the mensuration that you did in the 12. No. Just revolve around these past papers and get what's there and there. Then that's all. Okay. So
Sir.
Hello. So question 6 is done.
Sir,
Hello.
for us, mensuration, is it a topic on its own or they just fuse in some questions?
For us, mensuration is not even anywhere near like it's a topic. No. We just borrow formulas from mensuration. But in most cases, they'll be given. You've seen that in this question, this was given. This was given because we know that at least you won't forget the formula of the base, which is a circle. And so you know that the volume is just a derivative of what? I mean the area of the open cylinder is just a derivative of the whole cylinder. That's why we have that two down there. So we don't need much from mensuration, we just need formulas. Okay, let's log out and come back for question 7. We won't end this class until we are done with question 7. So let's log out and log back quickly.